Okay, so today is 10/21/19. All right, so if I'm going to graph f of x equals 2 to the x, let me just start with numbers, okay? If I plug in 0, anything to 0 power is 1. If I plug in 0, 2 to the 0 power, and you can use your calculator if you don't believe me, but it is, okay? If I plug in 1, then 2 to the 1 power is 2. If I plug in 3, 2 to the 3rd power is 2 to the 2 power is 4. And if I plug in 3, then 2 to the 3rd power is 2 times 2 times 2, which is 8. Now I'm going to plug in a couple of negatives because I'm going to at least need a couple of negatives. So if I plug in negative 1, if x is negative 1, I get 2 to the negative 1, which is 1/2. And if I plug in negative 2, I've got 2 to the negative 2 power, which is 1/4. It becomes a fraction, okay? 1/4. Okay, if I graph these points, I'm going to get a point at 0, 1, 1, 2, 2, 1, 2, 3, 4, and 3, 8. 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, okay? If I do the negatives, if I go negative 1, I'm going to get 1/2. If I do negative 2, I'm going to get 1/4, okay? What we've learned, and of course a lot of this you already know, which is awesome, makes it easier to do this, that's an exponential, and we know we're going to have a horizontal asymptote right there, okay? So these are things we do know. We've talked about this. Luckily, today's not a bad day because we've talked about it. Okay, there's my horizontal asymptote. There's my graph. Now, thumbs up. Am I going too fast? Okay. Now, if we want to do its inverse, the easiest way to do its inverse is just to switch the points, right? Just switch them around. So on the inverse, I'm going to go and have a point at 1, 0. I'll have a point at 2, 1. I'll have a point at 4, 2. I'll have a point at 8, 3. If I do the negatives, I'll switch those around. Have a point at 1/2, negative 1, and 1/4, negative 2. Okay. And if we graph those, so to do an inverse, I just switch the points. That's easy. If I graph those, I'll have a point at 0, 1 is there. 2, 1, point there. 4, 1, 2, 3, 4, 2 there, and then 8, 3 is off my graph, but I'll kind of like pretend it's right there, okay? Now, 1/2, it's about there. 1/2, negative 1, okay? And then 1/4 and negative 2, so I go 1, 2, okay? So my inverse graph would look something like this, okay? And it would have, instead of a horizontal asymptote, it has a vertical asymptote, okay? So that's at x equals 0. How am I doing so far? So far, so good? Now, if it's an inverse, we can get the inverse equation. Am I going too fast? Here comes the tricky part. You gotta watch. Here comes the tricky part. So if I'm going to do it right up here. If I have an equation, y equals 2 to the x. Okay, you guys watching? And how do I do an inverse? Well, I switch the x and y's, right? So let's switch x and y's and rewrite this as, it's an inverse, let's rewrite this as a x equals 2 to the y power. Okay, there's its inverse, okay? Okay, and I need to solve for y. Remember when we talked about the inverse, we said two things. First, I said you got to switch the x and y. Remember that? And the second thing I said is solve for y. Well, you can't solve for y when the y is up here unless you change it from exponential form to log form. And that's what we're going to do. We're going to change this from exponential to log. So that's why we learn logarithms. So we're going to rewrite this as a log base 2 of x. And that's the equation of the inverse graph. Y equals log base 2 of x. Go ahead, ask me.
Wouldn't it be y equals x?
So I'm
Oh,
right
wait,
here.
never mind.
No, that's okay. Lily always asks me because I'm bound to make mistakes, right? So cool. So here's what we know. We know that given an exponential, its inverse is a log. Say that again. Given an exponential, its inverse is always a log equation. Or given a log equation, its inverse is exponential. Okay. So now, if we know that, we've got the asymptotes in. What do we know about the domain of both these? So first of all, what's the domain of my exponential? What's the domain of my exponential? All real numbers. Awesome. Domain is x equals all real numbers of that one. So then what's the range of my exponential? What's my range of my exponential? Y is greater than, not equal. Really good though. Y is greater than 0 because it never touches here, right? Okay, everybody agree with what Austin said? Reach for your range. Does it ever touch 0? No, but it's greater than, okay? Now, watch. If I want the log one, the domain, what's the domain of the log graph? What's the domain of your log graph? It's x is greater than 0, and the range is all real numbers. So to me it makes sense because it's an inverse, everything switches, right? So the domain of this one becomes the range of that one, and the range of the original becomes the domain of the original. Okay? Now, let's take that and let's go ahead and grab it. So now, number 2, e to the x, all right? So e to the x is very similar to, because it's really like a y equals a 2.71 to the x. So it's very similar to what we have up here. It's going to have the same shape, a little bit steeper. Now, we don't have to be perfect on there. There's just 3 things. Listen, 3 things. 3 things I need when you graph these. Shape. It's got to have that shape. Okay? It's super easy. I need 3 things. Shape. It's got to have that shape. 2, I've got you have to go through the correct intercept. Okay? And then 3, the third thing I need is the asymptotes. Okay? So I need shape, x-intercepts or y-intercepts, and asymptotes. So this one's going to look very similar to this one. So I know instead of y equals 2 to the x, I do know it has to go through 1. Because anything to the 0 power is 1. It's going to have the general shape, maybe a little bit steeper. I don't have to have it perfect, but this is all I need. That's all I need. It's got to go through 1. It's got to have the right shape and have the horizontal asymptote at y equals 0. So, perfect, okay? Everybody okay with that? Okay, then number 3. It's got a negative here. So if I take a look at my original equation, here's y is equal to 2 to the x. If it's y equals a negative, what's going to happen if I make this one negative? The x is negative. What's going to happen if I make the x's negative? The x's are negative. The x's yeah, it just flips the other way. So it's going to this is going to reflect. So it's going to be a reflection over the y-axis. So it's going to look like this. And my asymptotes. All right, so I needed 3 things. I need the right shape, so I've got the right shape. It's going down like that. I need my x-intercept or my y-intercept in the correct place, and I need my asymptote. Okay. Now, worst case, you can always put in the calculator, right? You guys agree with that? Worst scenario, you're like, I have no clue what this looks like. Put in the calculator, right? Because the calculator can give you the shape. Okay. Okay. Ready to turn it over? Okay. Turn it over. Number 4, all right? Now, y equals log of x. What's the invisible base? 10. So we've got y equals log base 10 of x. So I could look at this one on my calculator, right? I mean, what the heck, right? I could go ahead and say, well, what does it look like? So I go, okay, I can do that. Clear y equals clear log of x. And the 10's there. So if it's base 10, it's our invisible base, right? We do base 10 because we live in a base 10 world. So then if I were to graph this, let's see what it looks like. Graph. It looks something like that, okay? If I wanted to get more accurate, I could use a table, right? And then I'm going to get like 1, 0. I know for sure 1, 0. I'm going to get about a 1, a 0.3. So let's go to 4 at about 0.6. 1, 2, 3, 4 at about 0.6 is maybe there. If I go to 6, about 0.77. 4, 5, 6, 0.77. So I got to go all the way to 10 to get 1, which makes sense to me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1. Okay. Now, what I know about it, because it's a log graph. Okay, so I got some dots. I'm going to flip the page in a second, but I'll flip it back. I know that it's a log graph. So it's going to have an asymptote, right? So I'm going to put the asymptote. In fact, the calculator kind of tells me. Check this out. You guys look at this. What's this error? Error. Can it equal 0? No. Can it equal negatives? No. Error. So I know for sure I'm going to have a asymptote right here. And then it's just going to take a dive. Okay, here it is. Let's look at, real quickly, this point right there. So you ready? 10 to what power equals 10? 10 to what power equals 10?
1.
Does that make sense? I got that point there? Okay. 10 to what power equals 10, 1. So the log makes sense. So then the difference is on the second one, if I'm going to graph y equals log base 2, again, I can't put that in my calculator. I can't. But I know it's the opposite of this. We actually did that graph, didn't we? So let's see if we can do that. I know for sure that, so 2 to the x, or the inverse, be y to the 2. So I know I'm going to have a point here. And if I go 1, 2, 3, 4, 4 to what power equals 2? No, 2 to what power equals 4? 2. 1, 2, 3, 4, 5, 6, 7, 8. 2 to what power equals 8? 3. And then it just takes its dive. So they're very similar, aren't they? The difference is one's a little bit taller than the other. And I've got to have my asymptotes in there, okay? All right, so today's homework, what we're going to do is just manipulate these. Okay, we're going to move them around. That's about all I have. Again, I can't emphasize enough to you that if you don't practice this stuff,